Construct a right-angled triangle containing an angle A such that sine A is equal to 0.4. So construct a right-angled triangle. Okay, so let's construct a triangle. Okay. Right. Sine A, so it must have an angle A somewhere. Let's fill it in. And just as in the other one I did, it doesn't matter if that angle A is here or here, whichever you prefer. Okay, and then let's label our sides. So here's my hypotenuse. That must be an opposite because it's opposite the angle. And then this for this one must be adjacent. Okay, so that's in any triangle that you're told to draw. I've done nothing more than draw a right angle triangle, labeled an angle with whatever letter they told me here, and then just put in opposite adjacent hypotenuse, okay? And then the last thing I'm going to write in is silly old Harry caught a heron trolling off America, okay? So that I know which sides are related to sine, cos, or tan. Okay, now in this one, the way they've given it to you is a little bit difficult. If I go sine A is equal to 0.4, but it's equal to, and if you can't convert that to a fraction in your head, put 0.4 as a decimal in the calculator and hit equals, and it will automatically convert it to a fraction for you. Why do we want it for a fraction? Okay, well, you can see up here that sine is equal to opposite over hypotenuse, okay? So when I write it as a fraction then, I can see that my opposite is length 2 and my hypotenuse is length 5. Okay, so my opposite is length 2 and my hypotenuse is length 5. Okay, and that's part A done then. You've constructed a right-angled triangle containing an angle A such that sine A is equal to 0.4. Okay, so if I get sine of A, which is opposite over hypotenuse, it's 2 over 5, okay, which as a decimal is 0.4. So that's that part done. Now, the second part, and this is the normal question that follows it, find from your triangle cos A in third form. So from my silly old Harry, I know that cos A is equal to adjacent over hypotenuse. Okay, so I don't have a length for adjacent yet, so I have to find it. I don't have any angles, I just have sides, so that lends itself to Pythagoras' theorem. So c squared is equal to a squared plus b squared, so it's always my hypotenuse squared equals 2 squared plus b squared, or adjacent squared. So 25 is equal to 4 plus b squared minus 4 from both sides. So 21 is equal to b squared. Get the square root of both sides so that you get b being equal to root 21. Okay. Now, common mistake here, I'm just going to show it to you while I'm here, is that people could write the side that I need, which was the adjacent squared, equal to 5 squared plus 2 squared, okay? Our adjacent squared is equal to 25 plus 4. Adjacent squared is equal to 29, so the adjacent is equal to root 29. Okay, that's a very common mistake to make. I'm just putting a red X beside it. Okay, on my calculator, I'm just going to put in root 21 so that I can see what that is as a decimal. Okay, now I'm not going to use the decimal, but I'm just going to write down 4.58. I'm also going to put root 29 in as a decimal, and you'll see I get 5.39 for that one if I round it. Okay, why am I telling you this? Well, if you know that the hypotenuse is always the longest side of a triangle, you will know that when you find the length of adjacent, it can never be greater than 5. Okay, so when I get down here to look at my answers, I always have a look at them and make sure that I haven't done something silly and that the side is less than my hypotenuse. This is a very easy mistake to make. So when you find that you have an answer greater than the hypotenuse, just go, ah, I put the wrong side here for c squared. Okay, so then you just lightly, for your examiner, put a line through that. Okay, and then just do it as we did it in blue. Okay, so don't go mad fixing it out. It's a common mistake. Just put a line through it and redo it again. Okay, right, so cos A then is adjacent, which we have found is root 21 over your hypotenuse, which is 5. I'm having a final look up to see did they tell me to find the angle A or just leave it as cos A, and they told me to leave it as cos A. So that's good, that's me done. If I was to find A, I would be getting the cos inverse of root 21 over 5, okay? But I wasn't asked that. So this here is your final answer.